All right, our next unit, or excuse me, our next lesson in Unit 8, right triangle trigonometry, is going to involve the calculator. So what I want you to do is take your calculator, and I'm going to pull up a different one I have that I don't always use in class. But this is TI-84 calculator. The first thing I want you to do before we start the lesson is I want you to hit the mode key. All of the angles that we're going to be using are going to be listed in degrees. They'll have a little degree symbol most of the time. So go down to the third row, go over to the right where it says degree, press enter. Okay. See if it finally picks it up. My screen's working a little slow. So if it's black highlighted on degree, you're good to go. If it's not highlighted black on degree, then you're in the wrong mode and you will not get the right answers. All right, radian is a different way to measure angles, and it's used a lot in the more advanced classes. So sometimes calculus students might use a calculator in this classroom. So if you take one off the wall, it's a quick, easy step to check the mode to see whether or not it's in radians or degrees. Or if you ever do a memory reset, second, memory, and then when I do 7, 1, 2, reset everything, notice it says RAM cleared. When you do that, it takes you back to your default settings, which means everything is now to the left again. So if you change your batteries, same thing. It's like it resets everything. So if it might reset something, you might want to go hit the mode key, change it back to degrees. All right, we're going to be doing some calculator exercises. Let's begin by talking about this one right here. We just learned about sine, cosine, and tangent. And we know that SOH, S-O-H, CA, C-A-H, TOA is a way to remember sine, cosine, and tangent. Okay, sine is opposite to hypotenuse, cosine is adjacent to hypotenuse, tangent is opposite to adjacent. There is another way to remember it. Okay, my college professor used this one. He said, some old hippie caught another hippie tripping on apples. Tripping on apples. I don't care how you remember it. You can remember so katoa, or you can remember some old hippie caught another hippie tripping on apples. Okay. Now, keeping that in mind, I want to look and see what I have in this triangle. I have 30 degrees, so I have my angle. I have the side directly across from it that doesn't create it, and that would be opposite. And then I have 20, which is across from 90 degrees, so that would be my hypotenuse. I know I have the sine ratio, so this is sine. And the way I write it is just like I saw it in my foldable. I put the angle after it, so 30 comes next. And then it would equal 10 over 20. And the thing about 10 over 20 is it actually reduces. 10 over 20 is 1/2. Okay? Or sine of 30 degrees could be 0.5 if you wanted to change it to a decimal. All right? Now that's that smaller triangle. What about a bigger triangle that also has angle 30 degrees? All right? This time the opposite side is, so sine of 30 degrees is 25. And the hypotenuse is again across from 90 degrees, it's 50. Lo and behold, 25 over 50 reduces to 1/2. So the sine of 30 degrees in a different triangle also gave me 1/2 or 0.5. What does that mean? That means that every 30-degree angle will always have the same 0.5 answer, no matter how small the triangle might be or no matter how big the triangle might be. If it's 30 degrees, it's going to have a sine ratio of 0.5. So what I want you to know is every single angle that we could work with in a triangle up to 90 degrees has a number of sine, cosine, and tangent ratios that are already known. We don't have to come up with them new. They're already known. In years past, we would have tables in the back of the book. It would have sine on one column, cosine on a column, and tangent on a column. And you would go down with your finger down the page to like angle 30 and go across under the sine, and you would find the number 0.5. If you were looking for cosine of 30, you'd find a different number. Go over to a different column. If you need tangent of 30, you go all the way over to tangent. We no longer have to do that because our calculators can do it for us. So this is what today is about, calculator exercises. All right, let's look at our calculator. Mine is turned on, ready to go. Notice that above the 7 key, above the 8 key, above the 9 key, is sine, cosine, and tangent. So if you haven't had a chance yet to use those, that's what we're going to do today. So when it says sine of 30 degrees, we're actually going to type this into our calculator exactly the way it looks on the screen or on paper. So I'm going to say sine, and I want you to notice that it opens up its own parenthesis, 30 degrees. And I like to make a point of typing in the angle, 30, closing my parentheses. Answer is magically delicious. Guess it's pausing. Finally, 0.5. Just like we mathematically saw with our thing, it is 0.5. I could do cosine of 30 degrees. Even if you don't close the parenthesis, as long as that's the only angle you're working with and there's nothing after it, you can kind of get a little bit lazy and leave off the parenthesis. But I don't like to do that. I like to put my parentheses on there. Tangent of 30, closing my parenthesis, can give me a different ratio. Okay. So it's as easy as putting these numbers in the calculator. So let's just see if we can do a few. All right. We're going to pull up our calculator, and we're simply going to take a couple of minutes to type in some ratios. All right. Sine of 30, I believe we know is 0.5. What about tangent of 30? I think I did that one, and I got 0.577. All right. For purposes, it says the nearest 10 thousandths, which is 4 decimals. I just simply am be satisfied with 3 decimal places. All right. So for this one, it says 0.57735. 0.57735. I only want the 5, the 7, and the 7, and you look at one number. That is not enough to make it to 578, so it stays 577. So you can pause the video, and you can just simply take the time to put these in your calculator. This is just a calculator exercise. All right? Calculator exercise. All right. I hope you paused the video and that you took time to go through, and that you can verify these answers. All right. Now let's move to the next part. Recall what we just did a few minutes ago that said the sine of 30 degrees is 0.5. But what if you forgot the angle of the sine that gave you 0.5 as an answer? In other words, you forgot about this, okay? So I have the answer, 0.5, but I simply need the angle that gave me that. So we could actually leave a blank space or a box, or we could even put a letter to represent something that's missing. So this would actually be a B angle, which I'm looking for degrees. All right? Well, we know the answer is 30 because we just worked with sine of 30 a couple of different times. So what we're going to see for the first time is we're going to use our inverse functions. Yes, inverse is popping back up. So when you need to use inverse, it's going to look like this. This -1 shows that it has an inverse. It's a little different than finding the inverse where you switch the x's and y's, but it still indicates something that undoes something else. So if I take the sine of an angle, I get the answer. But if I take the inverse of the answer, I end up getting the sine. So it does kind of work in a similar way. All right, so let's see if we can write this. I'm going to say that I'm going to take the inverse sine of the answer, which is 0.5, and I'm going to get the angle, which I've listed as B. Now, if you need to know how to do this on your calculator, and you all do, so let's just see what it looks like on the calculator. Look above the sine key. Do you see sine with a little -1, exponent? Cosine with a little -1, exponent? Tangent to the little -1, exponent. Okay, what those stand for is inverse sine, inverse cosine, and inverse tangent. So sine with a little -1, we say inverse sine. All right. It does not mean sine to the -1 power where you would move the sign downstairs. No. It works differently with sine, cosine, and tangent. Cosine to the -1 means inverse cosine. All right. And tangent to the -1 means inverse tangent. All right. And here's the biggest idea for this slide. Use inverse to find angles. If you have the answer and you have to kind of work backwards to try to figure out the angle, then you need inverse cosine, inverse sine, or inverse tangent. All right, so let's see what we got here. All right. I'm going to go second button, sine, and notice that it says sine with a little -1. That's what I want. I'm going to type this right here in, sine -1 of 0.5, and it should equal my angle. So 0.5, I like to close my parentheses, enter. And magic, waiting. Apparently we're a little slow with the calculator today. Inverse sine of 0.5 is 30. All right, which we knew it was. Okay, let's see what it looks like when we put inverse into play. All right, after you did 1 through 12 on the second sheet that I would have given you in class, okay, you now are getting ready to find the measure of the angle to the nearest degree. So when you are getting ready to do these, we're going to have to use what? Use inverse to find angles. Again, stating that so you don't forget. This is something really kind of important that you know the difference. When do I just press regular sine key, and when do I go second sine key? Second for inverse sine. All right. Notice that here, sine of some angle, this one is angle A. I have the answer, so it's like I'm working backwards to try to figure it out. So that's going to go in as inverse sine of the answer, 0.6248, and that's going to give me angle A in degrees. So let's see what happens. Inverse sine, second button, inverse sine, 0.6248, close parentheses. If I could type the right number, 0.6248. And press enter, and it tells me the angle is 38.6. It does tell me to use it to the nearest degree, so to the nearest degree is it 38 or 39? Should be 39. So number 19 is 39 degrees is how much the angle A is. All right, 14 says tangent of B. So I know the tangent ratio of whatever angle B is turns out to be this. It's like I have the answer. How do I work backwards to get the angle? The answer is use inverse, okay? And this time I'm going to use inverse tangent. So that's a tangent with a little -1 above it of the answer, 7.2483. And that's what I'm going to type on my calculator. So make sure that you do the second key before you press the tangent key. Make sure you go second. So I'm going to go second, inverse tangent of the answer, 7.2483, close my parentheses. 82.1, is that 81 or 82 or 83? I believe that's 82 degrees. All right, these are pretty straightforward. What happens when you go to 15 and it says cosine of C? I have the answer ratio. I have the decimal equivalent of the fraction ratio. How do I work backwards to get C? So I have to use inverse. Okay, so that'd be inverse cosine with a little -1 of the answer, 0.4233. And that would equal C in degrees. So now let's try inverse cosine. We've not done an inverse cosine yet. So I have to go second key, cosine key. And it does come up cosine -1, 0.4233. Close my parentheses. And 64.9. Is that 64 or 65? I believe that's 65 degrees. So we've done one inverse sine, one inverse tangent, and one inverse cosine. Whatever the ratio is, if it's identified as sine, cosine, or tangent, you take the inverse of that same function to get your answer. All right. Pause the video if you'd like and see if you can finish. All right. I hope you paused the video. I hope you actually went through the exercises to find your inverses. All right. Now, just to see how we can do on knowing when to use regular versus inverse, I want you to pause, and I want you to actually write down maybe on the side of that homework paper or on the side of any scrap or notebook paper, and I want you to ask yourself, if I saw number 1, sine of 35 degrees equals X, would I press the regular sine button, or would I go second because it's an inverse? Okay, so I want to know, is it regular or inverse? So pause the video, see what you come up with, and see if you get the right answer. All right, I hope that you paused it. I hope that you come up with an answer. If it says sine of 35, it gave you the angle. So that's just regular sine. I type it in exactly the way it looks, so it's regular. Number 2, it's like sine of A. Uh-oh, they don't give me the angle, they give me the answer. So it's like I have the answer, I have to work backwards to find the angle. That's a clear case of when we use inverse. Number 3, cosine of B is equal to 0.75. I have the answer. I got to work backwards to get the angle. That's inverse. Number 4, tangent of 17 degrees. They gave me the angle. So I type this in straight into my calculator using the regular tangent key. And finally, tangent of angle theta is 22.421. So I'm going to have to take the answer, work backwards to find the angle. That's when I need to use inverse, and I'll use inverse tangent. All right, this is your lesson on writing and